Would it be easier to start by maybe combining some of the resistors,
Like which ones?
like the 850s, because they're both on the
You
same.
can.
And there's nothing between them.
You
so-
can. You can combine the 850 and 850 and make that what? 1700?
Mhm.
It's not going to shrink it really that much. The question is, can I combine the 850 with the 850? I said, sure you can. They're connected in series, but it's not going to make the problem easier.
Okay. I was just curious.
You just want to see me redraw that one.
No.
850 and 850 is 1700.
Mm-hmm.
Okay. 1 meg, and there's still V1. We're looking for V1, by the way. And this is 250, and there's the ground. That's all we did. You know, it really didn't make much of a difference. Now, we said a couple of things last time, that the voltage at this end, V plus, equals what? V minus. And the other thing we said, the current going in or coming out here is 0. What about that current here on this end? That's not 0. There could be a current coming down this way. Yep, sure, absolutely. There will be current coming down this way. So this current is not 0. This is not 0. I'll put a question mark. So I don't think, oh, that's a 0 going that direction. The reason this is a 0 for ideal op-amp, the assumption this is infinite resistor here. If I draw the rest of the circuit, this will be a resistor of 0 here with a dependent source, which I will be drawing the inside of that in a minute there to show you why. But the current going in here, it's not 0. Well, is there a way to find what V plus is? The 1 milliamp is going up there. Since there's no current coming this way, that's 0. What is the current coming down this way? 1 milliamp. Can we find what that voltage is? So what is V plus equal to? 1 milliamp times what? 10K, which is 10 volts. So the voltage here is 10 volts, which means V plus is 10 volts, and that means V minus is also 10 volts. V plus equals V minus. Let me assign current in this direction, that direction. Let me call this voltage V out. KCL at this node. KCL at this node.
Ix equals Iy.
Yep, Ix equals I sub y. What is I sub x? This voltage is 9 minus this voltage is 10 divided by 100 equals this voltage, which is 10 minus V out.
Wait, where are you getting the 10 oh, wait. The V out there.
Over 1700. My LCD looks like what, 1700? That's a negative 17 equals 10 minus what? V out? Negative 27 equals negative V out. What's V out?
27.
27.
We don't want V out, we want V1.
Okay, when V1, correct. So what is V1 equal to? It's whatever V out is, add to it. If there's a current here, we'll call it I sub Z, right? Add to it I sub Z times 1 meg. Well, what is I sub Z? I sub Z. Try again. Better answer.
Was it 0?
Why 0, David?
Well, it's not a circuit.
Correct. It's an open circuit. There's nothing here.
Trick question.
So it's 27 volts. So I sub Z is actually 0. Remember I said to you the current going in here, probably not 0? Let's see. We know I sub Z is 0. We know what I sub Y now. I sub Y is going to be what? 10 minus V out, which is what? 27 over 1700. What is 17 divided by, or negative 17 over 1700? Is that negative 10 milli? Where's my calculator? Negative 0.01, which is negative 10 milli. Yep. Let's call this current IW. What's IW? It's V out minus nothing over 250. 27 over 250, which is what?
Wait, where's IW?
The current coming down.
Oh, okay, I see it.
So what is 27 divided by 250? 0.108 or 108 milliamps. I'm going to call the current going to the op amp here. Can you see it? Let me bring that picture down. I'm going to call that current going to the op amp I op amp, IO. So if I do KCL at this node, what do we have? What's going to that node? I sub Y. What's leaving that node? I sub O plus I sub Z plus IW. And what is I sub Y? I have that somewhere. I sub Y is negative 10 milli. I sub O, I'm looking for it. I sub C is 0. IW is what? 108 milliamp. Negative 118 milliamp, is it? So the current going in or coming out of this is not a 0. And that's just the math to prove that's not a 0. I was just looking for V out. That was the question. What is V out? We did it. And what's V1? We got it. So this, the second part of it, just to prove that the current going through that, it's not really 0 on this end. It's 0 on that end, but not that end. Now let's do some cascaded. Well, you know what? Before I get to cascaded ones, I'll get to them later. Let me do another one. Let's put some dependent sources, make the circuit look a little bit ugly. Now this is, it's not one of the ones, the cases that we said we can memorize. So this is what I have. I have a source here, and the value of the source 2 cosine 100t. 2 cosine 100t in millivolts. That's in milli. I have 100 ohm here. I have a 1K. This voltage I'm going to call V pi. Ten to the minus 3 V pi. One K three K and this is V out. So you need to find V out if V1 equals that value. 2 cosine 100t.
Can you move it over to the left a little bit? Otherwise, so you can see what that incense.
2 cosine 100t in millivolts. AC, yes.
So we're doing phasing?
Notice we even discussed AC. It doesn't really matter in terms of my calculation. I don't change a single thing. This is my VS, the source. So if this is VS, that's it. I can find V pi first. Yep, I get V pi here. V pi, it's voltage division. It's whatever the source is times 1K over the sum of them, 1K plus 100.
Is there actually like one wire between those two things?
Where? Here?
Yeah, just one.
That's a wire, yes. This is a wire too. So this is 1,000 over 1,100 VS, which is what? 10 over 11 times VS. Whatever VS is, I can put that number now. I'll leave it for now. I said I'll leave it, then I changed my mind. No reason. $20 over 11 . Now, notice the source here, that dependent source 10 to negative
So
3.
what does this problem want us to do?
Calculate V out. 10 to the minus 3, okay. Interesting. Interesting. Did I draw the picture correctly? Let me just see something here. Where is it? Where's that picture? I drew the picture correctly, yep. Now watch what happened. I just had to take another look at it. What's this voltage here? What's this voltage here? What's this voltage here? What's this voltage here? The way the picture is drawn. They have this ground and that ground. Should be my blood number. Hello? Yes. Lakeisha, how are you? Good, thank you. Yep. Okay. Thank you. Bye-bye. I like having my own machine at home. I check mine at 5 in the morning. I don't have to go anywhere. Oop, I didn't mean to do that. Okay. When is it? It's gonna put that date there. October. Oh, I'll do it later. October 23rd. Just gotta remember that. So that will be the value. But if this is 0 and this is 0, what is this current here then?
Zero.
That better be 0.
So
If-
is that current source up there, is that going into the ground?
Which one?
The 10 to negative 3?
This one?
Yeah.
That's attached to this node, which is the ground, yes. That means there's current coming out of this way. There's a current going this way of the value 10 to the minus 3 V pi. Well, if you do KCL at this node, what's this current? It can't be 0.
The negative 3.
10 to the minus 3 V pi, because this is 0. This has to equal to this. This is 0.
So it's coming from the
So-
amplifier then?
Oh, okay. So then across the 3K ohm resistor would be 10 to negative 3 V pi.
This current has to be this current. It's going that way. That tells me this end here, voltage is going to be like this. So this end is going to be whatever this voltage, so V out now, is going to be whatever this voltage, which happens to be what? 0. Add to it 3K times what? 10 to the minus 3 V pi. This is whatever this current times that voltage drop here. This current times the resistor, that's the voltage drop, and this end is higher than that. That's what V out is. 10 to the minus 3 and the K's, they cancel each other out. 3 times 20, which will be what? 60 over 11 cosine 1000 T millivolts. So 3 times that number.
So you didn't have to use that first part of the circuit?
Well, I did find V pi, right? I had to find what V pi is, and that's this number. So this first half allows me to find V pi. I looked back to see if they really have two grounds, to see if that's a ground, that's a ground. So yep, this is ground. I looked at the picture. Well, if this ground, this is 0 voltage, this is 0, this is 0, there's no current going through that. This current down is this current. That means it's coming from here, which means coming from up there. So V out equals 60 over 11 cosine 100t millivolts.